What is quantum circuit depth? Imagine trying to complete a complex puzzle where some pieces can be placed at the same time, but others need to be added one after another. That's a bit like what quantum circuit depth is all about. It measures how many layers of quantum gates or operations are needed to finish a quantum task. Think of each layer as a step in a recipe. If you can do many steps at once, the overall process takes less time. If you have to do each step one after the other, it takes longer. In quantum computing, gates are like tiny switches that change the state of quantum bits, or qubits. Some gates work on just one qubit, while others involve multiple qubits working together. When building a basic quantum circuit, you want to arrange these gates efficiently. The goal is to make the circuit as shallow as possible, meaning fewer layers, so it runs faster and with fewer errors. The depth is also about dependencies. Sometimes, one gate has to wait for another to finish because they share the same qubit or because of how the qubits interact. This creates a chain of steps that can't be done in parallel. The longest chain of dependent gates determines the overall depth of the circuit. Why does this matter? Because real quantum computers have limited coherence times. That's the amount of time qubits can stay in their quantum state before errors creep in. If your circuit is too deep, it might take longer than the qubits can hold their quantum information, leading to mistakes. So, keeping the circuit shallow helps make sure your quantum algorithm works correctly on actual hardware. When building simple quantum circuits, you can reduce depth by doing things like rearranging gates to run simultaneously or breaking down complex multi-qubit gates into smaller, parallelizable steps. For example, instead of applying a complicated gate all at once, you can split it into smaller gates that happen at the same time. This way, the circuit becomes shorter in terms of layers. In practical terms, a lower circuit depth means your quantum program finishes faster, which is especially important when working with noisy hardware. It also means fewer chances for errors to spoil your results. Hardware with limited coherence times needs circuits that are just the right size, not too long, not too complicated. Overall, quantum circuit depth is a key measure that helps us understand how efficient and feasible a quantum algorithm is. By minimizing depth, we make quantum computations quicker, more reliable, and better suited for real-world devices. It's a balancing act between the complexity of what you want to do and what the hardware can handle comfortably.